Hi and welcome to this video tutorial in which I will be guiding you through the working out and the answers to this paper 3 of the higher tier Edexcel Exam Board 2017 GCSE Maths paper. So without further ado, let's get started. Alright, question 1, guys. We have a Venn diagram question. We have this universal set which consists of the odd numbers up to 30, and we have set A. So let's go ahead and mark it here. And we have set B. The common numbers like 15 will go in the overlapping area, so let's put that in there, and the other numbers will go in their respective sets. So 3 goes in here, we have a 9, we have a 21 and 27, and for B we have a 5 and 25, and the rest of the numbers, odd numbers up to 30, will go in this space here. So we're gonna start by writing them down. So that's 1, 3 is there, 5 is there, the next one will be 7, 9 is already there, 11, 13 I believe, alright, 15 is there, 17 is next, 19, 21 is there, 23, alright, and let's write it down, 25 is there, 27 is there also, so the next one is 29 and the last one. Alright, good. Part B is what is the probability that the number taken at random from the universal set will be a number from this set here, A union B, all this there. Okay, so what we have to do, count how many numbers inside this union A and B, or A, yes, A and B, right? I should say A or B, doesn't matter, right? So it's going to be 1, 2, 3, 4, 5, 6, 7, and it's going to be 15 altogether. So up to 15, right? So that's how we do it. Next question is question 2. Question 2 is on simultaneous equation. I always like to start by numbering my equation 1 and 2 and find out which variable is best to eliminate. You can see here x is the best one to eliminate because you have 3x in the first equation and also 3x in the second equation. So let's go ahead and eliminate x, and in order to eliminate x we need to subtract 2 from 1. Right, so we do 3x minus 3x becomes 0x, and then we have 4 minus 4y. So did I say 4? No, y minus 4y. Y minus 4y will turn to plus 4y, right? So that will be 5y here. And on the right hand side of the equal sign we have minus 4 minus 6. That will give us minus 10. Okay, so basically you can see y is equal minus 10 over 5, which give you minus 2. That is your first solution. Let's write it down here, y equal minus 2. Now we need to find x now, so we need to, I'm going to use 1, okay, so I'm going to substitute this value here into 1, so we'll have 3x plus minus 2 equal minus 4, because now y is becoming minus 2, which is taking the value of minus 2. So let's do that. This 2 here will change to minus, so we have 3x minus 2 equal minus 4. Alright, we're going to do plus 2 both sides to eliminate the 2 from the side, so we'll be left with 3x equal minus 2, and then we divide by 3 here, and we divide by 3 here. This will give us x equal minus 2/3. So that is this next with the second solution, x equal minus 2/3. All right. Next question is question 3. Well, question 4. Daniel bakes some 420 cakes with different flavors. We've got vanilla, we've got banana, lemon, and chocolate. We want to calculate the number of lemon cakes he made. All right. Okay. So let's do vanilla first. How many vanilla cakes he made? He made 2/7, okay, as a fraction. So we need to multiply it by 420, and that would give you 120 cakes, vanilla cakes. Okay, let's do the banana cakes. We're going to call it B. That's 35 times 420, and you divide it by 100. Okay, when you do the calculation, you get 147. Okay, next we're going to add this to here. So we do, well, add them together, the total 120, add 147, that gives me 267. Okay, we're going to subtract this from the number of cakes he made. All right, so we do 420 now, minus 267, and that would give us 153. Right. So far, let's think about what we've done. We calculated the number of vanilla and banana, added them together, subtracted total from 420, and we got 143 cakes. Those 153 cakes, sorry, are the lemon and the chocolate. So that, okay, that's what this figure represent. Now we need to share it into this ratio 4:5, or we can say lemon has a fraction of 4/9, right? And we multiply it by 153. Right, since this is a calculator, go ahead and do the calculation. All right, and the answer is 68. Okay, so we have 68 lemon cakes. All right, that's how we do it. Next question is question 5. Right, this question number 5 is on angles in polygons. Right, few recap on angles on polygons, and specifically for this exercise, we're going to use the property of exterior angles because they add up to 360. All right, basically, if you do the number of sides, okay, and times it by the exterior angle, okay, that give you 360. Right, in regular polygons. What also we need to work out or use, right, is the sum of the interior angle and exterior angle. You know, they should add up to 180. Right, for example, if you have this corner of a regular polygon or any polygon, this is your exterior angle. Let's call it E, like we did here, and this we call it I, right, for interior. So basically the two add up to 180, and you can see because it is straight line, so a straight line. Okay, so we're going to use that. Okay, right, so first thing you need to do, we need to calculate the angle C. Right, we know the angle this one of the square is 90. Why do we need to calculate the angle C? Because I wanted to calculate angle P, right, and then use this formula to work out the number of sides for the polygon P, and then I will decide what hexagon, if it is a hexagon, sorry. Okay, so now angles around or at a point add up to 360, so therefore we need to add this to first. Okay, sorry, I apologize, I need to calculate, yes, first I need to calculate the angle C in the 12-sided polygon. So let's do that. So in the 12-sided, so the 12-sided, let's write it down here, 12-sided. So in order for me to calculate the interior angle C, I'm going to use this little formula there. Okay, so first I need to find the exterior, so I'm going to use this. Okay, I'm going to do 360 divided by the number of sides, which is 12, or sides. That will give me an angle of 30 degrees. That is the exterior angle in the 12-sided polygon. So therefore, C should be equal 180 minus the exterior angle, 30 degrees, and that gives me 150. So basically, C is 150. Let's write it down. Right, what do I do with it now? I need to add it to 90 and subtract the answer from 360 to get the interior angle of P, or polygon P. Okay, so let's do that. So now we're going to do a polygon P. So we're going to do the interior angle, right? First we're going to do 150 plus 90. That gives me 240. And then we're going to do 360 minus 240. That gives me 120. Okay? So that is the angle, the interior angle P. Right? So and then we're going to do, okay, this. So basically we're going to do 180 minus 120 to get 60. Alright? And then we're going to do 360, this one here, divided by 60, and that gives me 6. That's 6 sides. Okay? So polygon P has 6 sides. So therefore it's a hexagon. Okay? That's how we do it. Next question is question 6. Question 6 is a question on density calculation. The formula for density, you know it, is mass divided by volume. So therefore, in order for us to calculate the mass, we need to do density times volume. Okay? Right, so we're going to use both. But first we're going to start with this one here, because I need to calculate the mass of apple, the mass of the syrup, and the mass of the carbonated water. Okay? Because I know their densities there, and I know the volumes used for each ingredient. Okay, let's do that. So first we're going to do apples. The mass is going to be 1.05 times the volume is 25. We do the calculation later. The syrup, we have 1.4. We're going to time it by 15. And for the just water, I'll write it down for now. The density is 0.99. We're going to time it by the volume used is 280. Okay, let's go ahead and do the calculation. So I got for apples 26.25. 26.25. That's grams, of course. For the syrup I have 21, and for the water I have 277.2. Now what's the next move? We want the density of the drink, so we're gonna go back to this formula. We're gonna use it. Basically the density is going to be the total mass, so we're going to have to add all this, 26.25 plus 21 plus 277.2. okay, and we're going to divide it by the total volume, which is 320. Right, plug all this in a calculator and you get an answer as to 2 decimal places, 1.01. okay, 1.01. I should put a squiggly equal sign there. Okay, means that is rounded. 1.01 the unit is gram per cubic centimeter, and the accuracy 2 decimal place. All right, so that's the answer to exercise 6. Question 7 is next. Question 7 is on trigonometry and Sokotois. We need to calculate the length of AB. Now AB is opposite to the angle, so it is opposite, of course, and the hypotenuse, that one. So we're using opposite and hypotenuse, so we have to use the sine trig function. Sine 23 degrees is equal AB divided by the hypotenuse, which is 15. So therefore we make AB the subject, and that will give us 15 times sine 23 degrees. and you do that and you get the calculation, you get the answer to 3 significant figures. Okay, I'm going to ignore all the for now the digits that are which are displayed by the calculator. I'm going to go straight to the rounded figure, so that's going to give me 5.86 and 3 significant figures. Okay, all right, that's the answer. Next question is question 8. Question number 8, we have a circle, and in that circle we have a square of length x. We need to calculate the value of x, so therefore we need to use Pythagoras, because that is the right angle triangle there, if you allow me to illustrate. Okay, that is x. That should be the same, but just a little sketch there. Now the diameter, as you can see, is our hypotenuse, so basically this is the right angle, so you can see we have to use a Pythagoras, so that for x squared plus x squared equal d squared. Right, now in order for me to calculate x squared, I need to find d, the hypotenuse. All right, and in order for me to find d, I need to find the radius, which is this one here. Right, the radius is this there. Okay, the radius there. Okay, this is the center C. Okay, and so therefore I need to use the area of circle. Pi times r squared is equal 49. So basically r is going to be equal 49 over pi and square root. Okay, let's plug this in a calculator and see what it gives us. So the answer for that is 3.9493. I'm going to leave it there and I'll write down so on like this. But it's not the radius I need the diameter, so I need to multiply this by 2. So go ahead and multiply it by 2 to get the diameter. Alright, while you still have all the numbers with all the digits on your calculator. So go ahead and do that. What do you get? I'm going to do that straight away, times 2, and that gives me 7.8986 and so on. Leave it there. Okay, now let's go back to our formula here, the Pythagoras one. So basically here it's a bit of algebra. It is algebra. We've got x squared and x squared. That gives me 2x squared equal d squared. Right, so therefore I have x squared equal d squared over 2. So basically I can say, if I square root this one and square root both to get x, I will get square root of d squared over 2. Okay, now since I have the d here, this one still displayed in my calculator, I'm going to go ahead and square it. Okay, let's do that. Square it equal, and then divide it by 2. I'm just plugging this in the calculator, and the answer, I'm going to square root the answer. Yeah, and that would give me 5.5851 and so on. We need to round it to 3 significant figures. It's going to be 1, 2, 3. The fourth one is 5, so the 8 has to go up to 9. So the answer is 5.59 centimeters to 3 significant figures. All right, and that is our answer, and that's how you do it. Okay, all right, next question is question 9. Right, question 9 is a question on box plot diagrams. A, we need to look at the interquartile range. Now I need to find the lower quartile range, lower quartile, apologize, and upper quartile. So interquartile range has to be, without a lot of writing, you know the formula. I need first to work out the upper quartile. First you need to realize the scale, which goes up in tens. Okay, I believe, no, in 20s, apologize. 20, 40, 60, 80, 100, 110, 120, 140. Okay, so that is 140. I'm going to say that is the lower quartile. I'm going to write it down here. The upper quartile is going to be 330. Okay, and the answer for that is for me is 190. Okay, all right, so next one is we need to draw this box plot for the girls. Okay, so we need to do it. Okay, right, so I've done my best to draw it like this, but in your case, on your exam paper, you should do a better job than mine. Okay, right, so that is for the female. Make sure you label it. Okay, female students. Okay, all right, now that's done. Now part C, Chris says the box plot shows that the female students spend more money than the male students. Is he correct? Give reason for your answer. Yes. Okay, because you can see the median for the female is bigger than the median for the boys or the male. Okay, right, so we're gonna say that. So I wrote down this little sentence to complement, to explain, or to give a reason. Median for female is greater than median for male. Okay. Okay. Next question is question 10. Question 10. We have Naobi invest £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth £8,029.35. Work out the value of X. All right, let's get started with this one. Now, the formula for calculating the investment is going to be, let's write it down, 8,029.35 is calculating by multiplying the deposit or the investment, 6,000, by the multiplier to the power of 5. Okay, so let's go calculate the multiplier and then find out how to get the compound interest. Let's do that first. So m is going to be to the power of 5, sorry, it's going to be that divided by that. Okay, so we're going to divide 8,029/35 over 6,000. And then to work out m, you need to do the inverse, which is you need to elevate this to the power of a fifth. What I mean, you need to, on your calculator, you need to do this, of course. Let me just rewrite it again. Over 6,000, and you need to do it at the power of a fifth. Okay, yes, power of fifth. Or you could do it as a fifth root. Okay, so this one also will be, if you know how to use the fifth root in your calculator, and I think you do, so it will be quicker. Forgot to put there, 35, and we're dividing it by 6,000. Once you've done that, you get the answer is 1.059. Okay, 1.059 recurring. Okay, leave it like this, don't round it, we're gonna round it at the end. Now, how do I work out the interest from this? Well, you know, the multiplier is calculated by using the percentage, original percentage, which is 100, and then you add the interest that is paid by the bank, and you divide it by 100 to change it to a decimal number, because a multiplier, as you can see, is a decimal number. Now let's reverse the process, sorry. So let's do first, I'm going to break down this fraction. I'm going to write it down as 100 over 100, or split the fraction, and maybe I should have said, plus x over 100. Now you can see this is giving me 1. Okay, let's write it down here. 1 plus x over 100. So that is my multiplier. That's how you do it. Okay, now if I was to write, replace this in here, I will have 1.059 recurring is equal 1 plus x over 100. And then if you do minus 1 to both sides, you get 0.059 recurring equal x over 100. And then you multiply it by 100 both sides. Okay, that will eliminate 100 from this side, and you get x equal 5.9 recurring. Okay, so therefore we're going to round it to 6%. Sorry, 6%. All right, and that's how you answer this question 10. Next question is question 11. Question 11, to calculate the different ways of the combination, you do the number of the shrubs multiply the number of rose trees. That's how you get it. So in order to check whether this is correct, we do 215 divided by 17. If you do that, go ahead, what do you get? You get 12.6 something. You get a decimal number. It can't be, right? Because a number of rose trees has to be a whole number. Okay, so the answer is no. All right, next question is question 12. First, let me draw a line where I would place the letters A, B, not into any scale, C, D. Just we're going to need it later to illustrate. Now we're going to write down, or rewrite I should say, the first relationship AB to BD. I'm going to write it down like this as normal, 1 to 5. Okay, this is a bit confusing. Right, now I'm going to write down as a fraction from A to D of AB. Okay, AB over the total, it is 1 out of 6. And for the other segment B to D, you can see it is 5 out of 6. I'm going to do the same thing to the other ratio there, A to C, sorry, AC to C to D, which is 7 to 11, and their fractions, so AC over A to D is 7 out of 11, and for the other one, CD, it is 11, oops, sorry, yes, CD over A to D is 11 out of 18. So let's see now, I made a mistake, AC over AD, it shouldn't be over 11, it should be out of 18. Should be over 18. You can see now the denominator, it should be 18 throughout the all the ratios. So I need to change this one here by multiplying by 3. So this one has to change to 3 out of 18. And this one will change to 15 out of 18. Now we've got everything the same denominator as this. So let's do the ratio, work out the ratio here, the question they want us to answer. AB to BC to CD. Now AB, you can see is there. It has 3 shares. BC, we don't seem to have it, so we need to calculate it. I need to make some room to find or space to work it out. Let's do that. Right, so for BC, in order to get BC, this is the reason why I drawn the diagram with the line here. BC, to get BC is you do A to C minus AB, okay? So BC, let's write it down here. BC is equal AC minus AB. Now AC, we need to have it AC. It's that one there. Can you see AC? It's 7. Minus AB is the one we started with. It's 3. Or this one here, same thing. So therefore BC is 4. Yeah, BC is 4. What about CD? CD is already there. Can you see that? The last one we did is 11. And that is the answer to this question. All right. Question 13 is next. Right. Question 13 is a question on regions and inequalities. Right. First thing you need to do is to establish the expressions for the equations. All right. We've got 1, 2, 3. Let's do the easy one. This one here. This is y equal minus 2. Okay, now for this one here, the one that goes through the origin, this is simple one, easy, y equal x. And this one I drawn a right angle triangle there, so because I need to find the gradient. You can see the gradient is 2, the change in y is 2. We divided by the change in y is also, apologize, not 2, sorry, let me change that, is 1, okay, and the change in x is 2. It goes from 2 to 4. So basically the gradient is a half, or 0.5. So I'm going to write it down here, y equal a half x plus the intercept is this one here, 1. Now we have established all the equations. Let's go and find the inequalities. Let's start with this one again. It's easy. The graded region is above this line, so we're going to say y is greater than minus 2. All right. Now because the line is solid, so we need to put in the equal sign. Again, it doesn't have to be in any order. So let's do the y equal x first. Again, the region is above y equals x, so the inequality will be y greater or equal, because it is also a solid line, x. And the last one, the region is underneath this equation, so we're going to say less or equal, because it is a solid also. So we're going to say y is less or equal to half x plus 1, and that's how you do them. Okay, right, next question is question 14. Question 14 is a question on algebraic fraction. We need to simplify it. So in order to simplify it, we need to factorize the numerator and factorize the denominator. Let's do the numerator first. Do it first. It is a difference of 2 squares. It will factorize like this, x plus 4 bracket and x minus 4 another bracket. Okay, so that's that. For the denominator, it's a bit more challenging, but we should be able to do it. Should have 2x, and half should have x here, and because there's a minus there should be 1 plus and 1 minus. I'm going to put plus there and minus there. I need a minus 5, and at the same time I need 12 there. So if I do a 3 there, okay, yes, I'm going to do a 3 there and a 4. Okay, let's check it out, guys. 2x times minus 4, that gives me minus 8x, and 3x, 3 times x, that gives me 3x, minus 8 plus 3x gives me the middle. Okay, so it is correct. Okay, you need to double check, guys. Always double check your answers by expanding. All right, let's do that. So you can see that it's done now. You just simplify this, so the answer is x plus 3 and 2x plus 3. No, I apologize. X plus 4 here. Sorry. That one there. And the denominator is 2x plus 3. That is the part A. Next one is part B. Part B are asking me, or is asking me to make V the subject here. So in order to do that, I'm going to multiply both sides by V. Okay, this V here. So we're going to have a VW equal 15 t minus 2v. I haven't expanded, but I'll do that in a minute. I'm just going to go back what I've did to explain, because you need to multiply by minus v there. You need to multiply by v there and multiply by v there, and these two v's will cancel out. That's why we ended up with the no denominator, and v times w gives me wv or vw, doesn't matter which order. Now in this next line coming up, I will expand. So that gives me 15t minus 30v. Now I need to add 30v to both sides, because I want to eliminate the v and make it join to the other v there. So that gives me vw plus 30v is equal 15t. Right, now you can see v is a common factor factorize it to get plus 30 inside the bracket, 15t. So therefore V is equal 15t over W plus 30 is your answer. Right, question 15 is a question on area of triangle using the sine formula. The sine formula is half A times B times sine alpha. Okay, so let's put in the values. Now A is this side, if you like, B is this side, and alpha would be 45. So let's start substituting into the formula. So we're going to say half. I'm going to choose A is this one here, 2x minus 1, and B is this one here, x plus 3, and times sine alpha is 45, and that gives me the area, which is 6 square root of 2. Okay, now at this stage what I want to do, I want to tidy things up a little bit without expanding the two brackets. First I'm going to get rid of this 2 there at the denominator. So in order to do that, you multiply by 2 and you multiply therefore by 2 here as well. So therefore you will get a new expression, if you like, nicer one, x plus 3 and times sine 45. Now this time it's going to be equal 6 times 2 is 12. Okay. Next, sine 45 is equal square root of 2 over 2. We want to keep it as exact value. So we're going to plug it in here. All right. So with that, again, still no expansion to be done at the moment. Okay. 2x minus 1 x plus 3 times root 2 over 2 is equal 12 root of 2. All right, can you see that? Now if I want to get rid of the denominator, I'm going to do the same thing what I did here, times by 2 and times by 2. Okay, and that will give me 24 on this side, because 12 times 2 is 24 on this right hand side. Now I still have to deal with this square root 2. That's simple. Just a square root by 2 here, divide by square root of 2 here, and divide by square root of 2, because that would eliminate. Okay, now I have I can expand now. Well, let me first, before expanding the two brackets, just rewrite it nice and neat. Okay, so let's do the expansion now. So that's why you get, this is what you get when you expand and simplify. Now we still have to make it equal 0. So we minus 24 from here and minus 24 from there. So we'll get 2x plus 5x minus 27 equals 0. All right. Now this is a quadratic. I forgot to put 2 power 2 here. I do apologize, guys. I just realized. Okay, so it's 2x squared. All right. Sorry. It is a quadratic. Now with the quadratic you have two solutions, plus and minus. Okay, you know the solution are x equal minus b plus or minus square root of b square root minus 4ac over 2a. Okay, so now because we're talking about meters and distance and length, we need only to pick the positive answer, so we ignore the minus one, so we have to ignore that one. So we're going to use just the plus there. Okay, so I'm going to above that, just the plus. So let's plug in all the numbers. A equal 2, B is equal 5, and C is equal negative 27. Right, we're going to plug in all this in the formula. Okay, let's do that. Minus 5 plus square root of 5 squared minus 4 times 2 times minus negative 27, sorry, and all that divided by 2 times 2. Okay, plug that in a calculator and we will get 2.631 . 2.631 what else? 0, 4, and so on are other digits. We don't need them, okay, because we will be rounding to 3 significant figures, and that is 1, 2, 3. Okay, so x is equal 2.63 to 3 significant figures, and that's how you do it. Okay, next question is question 16. Question 16 is a question on iteration. We have the initial value negative 2.5. In order to work out x1, we need to do minus 2 minus 4 over minus 2.5 squared in our calculator. So go ahead and do that. So the answer to x1 is negative 2.64. So the next value we have to do, just while you still have this calculation still typed in your calculator, just replace that value by the answer, and that will automatically and quickly give you the next iteration. Okay, so for that one, x2, we have negative 2.573921028 and 46. Okay, I'm going to stop there. Okay, right, for x3 I'm going to do the same thing. I'm going to use this iteration and plug in answer. All right, let's do that, and the answer I got for that one is minus 2.603767255. all right. Okay, so that's the iteration x1, x2, and 3. Okay, so next question is part B of this exercise. Part B is asking us to explain the relationship between these 3 values, x1, x2, and x3, and the equation x cubed plus 2x squared plus 4 equals 0. So let's start with x cubed plus 2x squared plus 4 equals 0. Now I'm going to move the 2x squared and the 4 to the other side. So I do minus 2x squared minus 4. So I'll be left with x cubed equal negative 2x squared negative 4, or minus 4. Now I need to get to x. So instead of doing the cubic root, I'm going to divide by x squared. Divide by x squared here, and divide by x squared. So that will give me x, and here you see the x squared will eliminate, so I'll be left with minus 2, and here you can see I'm going to have minus 4 over x squared, which is similar to that one. So all I have to do now, put n here and n plus 1 here, and that will give us the iteration formula we want to. Okay. Question 17 is a question on accuracy of measurements and upper bound and lower bound. Now the speed is calculating using the formula distance over time. Okay. Now in order to answer this question, whether can be greater than 160 kilometers per hour, we need to do the bounds of the distance and time. Let's start with the distance. All right. Now the distance is measured to the nearest 10 kilometers. So the bounds will be was it 2? So I'm going to write it down as inequality. That would help me. All right. Well, if you didn't, that'd be fine. So as the distance is between less than 75 km and greater or equal than 265. Okay, that is the, so this is the lower bound and this is the upper bound. Okay, now for the time is the same thing. The measurements are to the nearest 5 minutes, so it's going to be the upper bound would be 112.5 minutes, and the lower bound would be 107.5 minutes. Okay, now this is in minutes. When you calculate the speed, the answer has to be km per hour, like here. So I need to divide by 60 here. I need to divide by 60 here. All right. So what do you do when you what do you get when you do that? Let's do that anyway. So I went ahead and divided by 60. The answer for the upper bound time is 1.875 terminating, and for the lower bound is 1.7916 recurring there. Okay, we'll deal with it later. Okay, now I want to find the greatest possible value, so I'm going to go first. Well, I'm going to go ahead and start doing the calculation actually. So I'm going to do the upper bound first. For the speed, now in order to calculate the largest possible speed, you need to do the largest possible distance. So that is this one here, 275. Okay, and we divide it by the smallest possible time. Okay, which is this one here, 1.79. I would write it down to 2 at this stage. Okay, now let's go ahead and do that. And the answer is 153.458, I think. No, actually it's 9, 8, and so on. I need to continue. You can see it doesn't reach 160. So I know there is no need for me to do the lower bound, because the lower bound will be smaller. All right, I saved myself a lot of time. Okay, now, so the answer, no. Could the average speed of the train have been greater than? No. As simple as that. And the calculation, we have shown all the working out. Okay, so the next question is question 17, or part B. All right. Part B says that Jake's assumption was wrong. The track was measured correct to the nearest 5 kilometers instead of the 10 kilometers. So we have improved the accuracy. So what does it mean to the upper bound and the lower bound for the distance? Because we're talking about the distance here. It means that the upper bound will get smaller, all right? So remember here, this is the upper bound. It should be smaller, okay? So it should be less than 275. So the answer, the speed will be less. So therefore, it will have no effect on our decision in part A. So let's go ahead and write that down. Well, so I wrote down this little paragraph here. Upper bound means for distance will be less. That's what we discussed. So therefore, the upper bound speed will be smaller. So therefore, the decision in part A will stand. All right? I hope this helped. Next question, question 18. All right, question 18 is a question on arc length, A, B to C, and it's a bit of circle theorem as well. Now you need to be aware that the tangent make a 90-degree angle with the radius. That is clear, right? Okay. Now the way I'm going to do this, I'm going to calculate the angle x here using trigonometry, sokotua, and multiply it by 2, because this angle is the same as this angle, exactly like the same, because the two right angle triangle are exactly similar. Then I subtract from 360 to give me the angle, because I need a formula to calculate the length of the arc ABC. Is the formula theta. Let's call this one theta, if you like, divided by 360 and times it by 2 times it by pi times it by r. That's the formula, of course, you're going to use, right? So let's do the calculation for this angle x, we're going to call, okay? And this is also x. You can see this is the adjacent to the angle x. So this radius there, or 5, is the adjacent. This is the hypotenuse, of course. So basically using adjacent hypotenuse, so it must be cos. So let's write that down. So cos x is equal 5/9. and you do the inverse of cos to get the angle x. You do inverse of cos, and you do that in the calculator, and you will get 56.2510. 25101. Okay, I'm going to leave it there. Okay, so yes, that is x, so we need to double it. So go ahead and double it and subtract it from 360. So we're going to do 360 minus twice that angle, 56.25101. That will give us the angle theta we are looking for to put in our formula. All right, let's go do that. Now I've got 247.4979, 4979, and there are other digits, but I'm going to leave it there for now. That's plenty. Right, so let's calculate the arc now. We read it. The arc ABC is 247.4979. We divide it by 360. We times it by 2, times it by the calculator pi, of course, and times it by 5. So just plug it all this in your calculator, and for that you get 21.59. That's plenty. Okay, and I need to round it to 3 significant figures. That will make it 21.6. The unit we use in centimeters. All right, and that is my answer. Question 19 is next. Question 19 is a question on solving quadratic inequalities. Right, I'm going to start by solving it for x. So we'll do 2x squared plus 3x minus 2 equals 0. That's what I mean. In order to do that, I need to factorize it. Trying to work out the numbers that are here. It's going to be minus 1. It's going to be plus here. Plus a 2 to get a minus 2 there. And if I did 2 times 2, that gives me positive 4x minus 1x. That will give me the middle term. So the factorization is accurate. So we're going to solve it for x. So this one will give me straight away, let's do it straight away, x equal a half. And this one will give me x equal minus 2. So the next step is to sketch the quadratic graph for this function here. So let's do that. And the graph I'm looking for looks something like this, where this point here is the root is minus 2, and this one here is the half. Now, my quadratic inequality is positive. We want the positive part of the curve. So if I try to illustrate this by going over it with the red, so hopefully that you understand. And same thing here. This is the positive part of the curve. It doesn't matter, okay? Now, this part here is the negative part. We do not want that. Right, so if I take any point from the curve and project it on the x-axis, it will give me a value that is, as you can see, bigger than half. Okay, if I do another one, it will give me another value even bigger than half. So basically, as I go that way, all right, I will find my solutions which are x greater than half to make the y function, or the function itself, positive. On the left hand side, on this side, we do the same thing. Just to illustrate, if I project a point on the x-axis, it gives me a value that is smaller than minus 2. You do another one as well, it gets even smaller as I go up on the graph. So basically, my solution are this way. So for the x, that's less than minus 2. Okay, so let's write down our solution. So we do x smaller than minus 2, and we say and x greater than half. So these are the two inequalities for our solution. All right, next question is question 20. Question 20 is a question on exponential graphs, like this one here. So they are of form like that one, of course, a to the power of x. You can see this point here that we're talking about is when x equals 0. So therefore, when x equals 0, you have a to the power of 0, which you know is always equal to 1. So therefore, this point A has coordinate 0, 1. Part B is a equation of a circle. Okay, they come in this form. So let's write ours to make it look like this one here. So we have x squared plus y squared equal, now 16 is 4 squared, right? So basically now you can see that the same. So what does it mean? It means that the radius is equal 4. Now for the center of this type of equation of circle, they have a center coordinate 0, 0, which is the origin in our grid. Okay, so let's call it C there. Now for the, we should call it O. That's all right, let's call it C. Now this circle here, well, we label it capital C. Okay, now the radius, right, inside the circle, or of the circle I should say, is 4. So this point here, because they want us to write down the intersection with the x-axis, so we have this one and this one there. So this one is positive 4, this one is negative 4. Alright, now this circle C has been translated by a vector 3, 0, and you know what this means. It means that 3 units to the right in the x direction, right, on the x-axis. Okay, so let's do that. I have a copy of this circle, exact copy I think, similar copy, in red. So let's see if we can move it. So I need to move the red circle 3 units to the right. Okay, so roughly like that. What is important is that you mark the intersection correctly. All right, now this circle we call it B. Okay, now this point here has moved to its new position, which is 4 plus 3 is 7. This point here has moved to a new position, which is this one here, which is minus 1. And the center has also moved to a new position, which is 3. Okay, these are the intersections they want us to write down on the x-axis. All right, so with this exercise of this paper 3 of June 2017 for the Edexcel exam board, we finished this video tutorial. Thank you very much for watching, and all the best in your exams. Take care.